So number 3 is obviously, if you haven't noticed already, the hardest problem here. It's going to require that you're adept at using your calculator, and so let's go ahead and take a look. We've got a cost here, a cost function of manufacturing X computers per day. Okay, and that's given to us by this formula. And let's keep in mind here, the X computers per day, you can't have a negative number of computers. You're not going to manufacture 0 computers in a day, so the X has to be greater than 0. You can't divide by 0 anyway. And then we have a range that has to be, the cost was going to be positive, and so we're being asked to determine the average cost of manufacturing 60 computers in a day. So if we understand that that just means that X is 60, then we can, as long as we already have our Y input, I'm selecting, if you watched the last video, I did problems 1 and 2 using Y1 and Y2, so Y3 I already had programmed in, but I'm selecting that one. And I don't need to graph it yet because all I'm concerned about is finding what the value of the function is when X is 60. Okay, well, I can do this. I can do second calculate value, and when X is equal to 60, and I get, okay, invalid. So you have to actually have the graph on the screen to do it that way. But what I could do is I can do vars. So I push the vars button. Second quit to get out of the first part. So let's do that. Start from a clean screen here, and we do vars. So that's right next to the clear button. And then we want to access the Y3 variables. So right arrow for Y variables. Function mode is already selected, so hit enter. And then again, our current function is listed as our Y3, so let's type a 3. And then I just want to use parentheses, and I want to input 60 computers. So our average cost of manufacturing 60 computers in a day would be the number you see here, $1,344.23. So $1,344.23. Okay. And what value of X minimizes the cost? Well, let's graph our cost function. Let's just zoom 6 to see if we get lucky, which I already know we're not going to get lucky. We've got nothing on the screen. So that feature that I told you before is zoom 0. Okay, for zoom fit. Okay, you can just type zoom 0 for zoom fit or scroll down. Zoom fit is going to help us see something, hopefully. Okay, so we get this, and keeping in mind that our domain is all real numbers greater than 0, and so is our range. But so in other words, we don't need to see the second or the third quadrants, or even the fourth quadrants. We just need to see the first. So let's adjust our window to an X min of 0, and we didn't really see a whole lot of the graphs. I don't think we're going to be limited to 10. Remember, the X represents the number of computers manufactured in a day, so I think that number is probably going to be bigger. In fact, we saw 60 computers in a day, so let's go all the way to like 200. Okay, just in case, and maybe that number might have to go up. The Y min is going to need to be 0, and the Y max, you can see, we don't see a whole lot of the graph. That's 99,000. I don't think it's going to be 99,999 whatever dollars, 51. So we can see that the cost of manufacturing 60 computers in a day is $1,344. So we probably get by with just 1,500 right there for the Y max. Probably, I don't know for sure. X-res 3, and let's see what happens. All right, we see a little dip in the graph, so maybe if we want to see a little bit more of the graph, we could extend our Y max a little bit higher. Let's say 10,000. Again, there's no exact science. That gives us a better idea what's going on. Okay, so we do see a low point here. We see a local minimum, and so all we have to do is second calculate minimum 3, and we need a left bound. So 0.1 for a left bound, and then I should probably check. My X max is 200, so I got to make sure I get past that. Second calculate minimum, left bound 0.1, and then right bound, again, the right side of the screen is 200, so we probably get by pretty easily with a 150. Enter. And then my guess My guess is going to be somewhere around something less than 150. So let's just say 100. Okay, and see if that gets us our minimum value. If you look closely enough, you'll see your cursor sitting right there at that local minimum value, and we can see what the local minimum value is, and whether we have to round to the nearest whole number or not. You can see the numbers. Okay, like 44. I don't think I can pause the video. Sitting in my classroom right now. 44 computers at a cost of $11.75 or so. And so let's just write that down. What value of X minimizes the cost? Well, that would be 44.457. 457. And that's it. That's how many computers minimizes the cost. So just over 44 computers a day minimizes the cost, the average cost of manufacturing that number of computers. So that would be the optimum number of computers to manufacture every day to minimize the cost. And again, looking at this graph here, it provides us with I shouldn't have drawn my y-axis right there, but nevertheless, we see that the function comes down like this and it goes up there according to what I saw on my calculator. And that value right there has coordinates. That point right there has coordinates 44 point, I'm going to just round to the nearest tenth, comma 1175.8. 1175.8. That's that local min. So I guess I'll do the back of this worksheet. Maybe I'll do that in class. We'll see if I have time later on tonight to do the video for this one.